Welcome everybody. Today we are going to see some basic points. One is the speed of traveling wave. Now when we speak about the speed of the traveling waves, then the speed which is being considered as regarding the wave, the speed depends upon what? So here it depends upon the elastic property and density of the medium. So here when we speak regarding the speed of traveling wave, now you know that the wave, suppose the ripples are being produced on the surface of the water in the tank or maybe in the vessel also, that time that speed is connected to something else. What is that? So first of all, speed of mechanical, because you have to do some mechanical process, and it depends upon the elastic property and the density of the medium. So here when you do the job, mechanical job, that job depends upon the elastic property. Why we call it as a elastic property? Because there will be no friction or there will be no resistance, and taking into notice the property known as elastic, it will have continuous speed without any obstacle, and therefore also density of the medium is also very important. Now we know that if we take an example of the oscillation of the simple pendulum, we find that after giving the oscillation and coming back to the point regarding that resistance of the air acting on that bob, simple pendulum, we find that in the displacement, when we give the displacement to the bob, that time the amplitude is maximum. Later on when we notice it, as the time passes away, we find that the amplitude of that oscillation becomes slow and smaller and smaller, and a stage comes when everything becomes zero, means the position is steady of the pendulum. So similarly, when we speak that when the amplitude was maximum, then amplitude becomes zero of the pendulum, and this situation, why does it occur? Because of the density of the medium. If the density of the medium is taken into notice, it is definitely going to help for the speed of traveling in the wave. Next is that the speed of the transverse wave. Transverse wave, we have explained two types of wave, transverse wave and longitudinal wave. In transverse wave, we know that the vibrations or the oscillations, or why we say that when it is the particle of the wave, when it gets displaced from its mean position, it vibrates to the perpendicular to the direction of the propagation of wave, means to the x-axis, because along the x-axis it is going to travel. Hence we say that the speed regarding the transverse wave, now we have to see then what are the factors, because traveling wave, just we are considering only like a ripple, it is going from one end to the another end. But when we say that we are going to consider the transverse wave, we know that the particles of that medium, they are vibrating but perpendicular to the direction of propagation of wave, means propagation is also going on. At the same time, the vibrations are also, means it is getting displaced from its mean position to and fro. So he says that this speed will depend on the inertial property like mass density. Now mass density is very important of the medium. Second, now mass density means you already know what is mass. So Mass and density, mass, volume, density, we call it, no, this term. So mass, density of the medium is very important in case of the speed of the transverse wave. Now we are going to see the wave produced on the strings are transverse wave. Okay, this is the initial condition that the string which we are going to take for the purpose of experiment, it is will be a transverse wave. Now when we say that it is a transverse wave, then the restoring force is provided by the tension T in the string. Now you know very well that vertical or perpendicular vibrations are produced to the direction of the propagation of wave, and hence inertial property, or we first of all we say that the restoring force, when we apply the force, we pull the spring or we pull the bob from its main position to some distance, and then we relieve it, then the bob starts making oscillations. When it starts making oscillations, we say that it tries to come back to its original position, means that time the restoring force is taking place. When we apply a force to the spring, you see that when we pull it in the outward direction, no doubt mechanical force is applied, mechanically we are doing the job, but the force is acting in the positive direction of x-axis. As soon as I relieve the tension, I relieve the force, the spring goes to the mean position and then it travels in the negative direction. So that time when it goes to the original position or in the negative direction of x-axis, that time we say that restoring force is provided. But whom? By the string. Because if we look to the simple pendulum, tension is there in the string, and when we mechanically give the force applied to the string, and as soon as we relieve our force, then restoring force starts working, and therefore we say it is provided by the tension in the string. Next is the inertial property, mass m. It can be determined from the mass of the string m and its length L, as m is equal to m by L. Now here a simple formula is being provided, inertia m is equal to capital M upon L. What is this a capital M? It is nothing but the mass of the string, and L is the length of that string. So if we take the ratio of M upon L, we find that we are getting inertial property M. This is one formula. Next is that the formula for the speed of transverse wave on stretched string is, now here we know that speed, or when we speak about the term velocity, so here he says that it is nothing but under root T by M. Now here when we say that this formula for speed of transverse wave on stretched string is V is equal to under root T by M, then that time this is also known as the formula for the speed of transverse wave on stretched string. So this is the derivation of the formula, which is beyond the scope of this book. Only we have to limit to that point only. Now next is article we are going to see is the speed of the longitudinal wave. Now earlier we have seen the transverse wave, now we are going to focus it on the longitudinal wave. Now here in this situation, your particle on the string or the on x-axis, it starts oscillating forward and backward. Means like the spring, one end is attached, is fixed, and other end we are going to apply the force. So during application of the force, the particles of the medium starts to vibrating. When it starts vibrating or oscillating, it oscillates in the forward direction as well as the backward direction. And when it oscillates forward and backward along the direction of the propagation of the wave, then this gives rise to compression and rarefication. Means this, you know that the spring which is used in the pen to operate, to make on and off. If you want to on the pen, you apply the pressure on the back end of that pen, and that force is applied to that spring, and that time what is happening, once you press it, that time you are compressing it. Next time when you apply the same pressure at the back end, then the point of the pen goes back, it becomes switch off, and therefore that condition is called as the rarefication. And this compression and rarefication travels in the direction in the medium which is having elastic property. There is no loss of energy. So here in that situation, the compression and rarefication causes because of the oscillation. Now if you look to the speed of the sound in liquid and solid, then the speed of the longitudinal wave is given by the Newton's formula, and that formula is very simple. That is V is equal to under root E upon P, where E is called the modulus of elasticity and rho is called the density of the medium. So here this is how the speed of the longitudinal wave is seen. So today we will stop here.